Hi, this is Sung from Sky Academy, and we've been just basically dipping our toes in the water when it comes to calculus, and we've been looking at limits. Okay, another mathematical concept that we need to look at in a little bit more detail is continuity, and that's fine, right? We understand whether a graph or a curve or a line is continuous simply because we put our pen on the page and we graph it, and we don't take our pen off the page at any point. So a line is continuous, this line is continuous until I break it, and then I start again. And at this point, or in this area of this particular line, the graph is discontinuous. So it makes a lot of sense. It makes a lot of intuitive sense that that would be the case. However, in maths, we are actually looking at how we can define or how we can test for continuity, okay? And there is a really simple test for continuity, and that is basically this. If the limit, a function is continuous at a particular point A, or x equals to A, if the limit as x approaches to A, either from above or below, or from the left or from the right, in this case it'll be the left to the right, is actually going to have a value, and that value is equal to what the function would equal to if we substituted x equals to A. Okay? So in other words, the curve will be continuous if the limit of x approaches A for f of x is equal to f of A. Okay? Now, what does that all mean? What that basically means is this, right? As a curve approaches a particular point from the left or the right, it's actually equal to that specific point that the curve approaches from either the left or the right. And that's basically what we're looking for. Okay? So let's have a look at a couple of examples. Alright? So I'll give you an example right now. Let's take, for example, y equals 11 minus 2x squared at x equals to 3. Okay, so how do we test for continuity? Well, we basically do this. What's the limit of x approaches 3 for 11 minus 2x squared? Alright, it's equal to 11 minus 2, 3 squared, which is equal to 9 squared is, 3 squared is 9, times 2 is 18. 11 minus 18 equals to minus 7, right? And when we substitute it in, right, 11 minus 2 to the power of 3 squared is also going to be equal to minus 7. There's no problem. The line is continuous at x equals to 3. And this is the left-hand side, and this is the right-hand side, and they're equal, right? So the line is continuous, right? But let me give you another example, and hold on for a second. Let me get my eraser. Let me give you another example for a second. Let me give you is x squared plus 9 all over x minus 3 continuous at x equals to 3? Well, let's have a look at the left-hand side of this equation. So the limit as x approaches 3 of x squared plus 9 on x minus 3. And let's have a look at the right-hand side. Right, now we can already see from the right hand side, yes, that this function is going to be something over 0. So it's going to be 18 over 0. Of course, 18 over 0 can't exist, so the function actually breaks down at that point. Okay, so there is no value. It's undefined. Alright? So from the outset, we know that this point can't be continuous at x equals to 3. Okay? So there's no point going on with this. Okay? So that's how we basically do continuity type questions. If a question were to ask you whether or not a curve is continuous, you would basically use this test. Thank you for watching.